Okay, as I was saying, we have a file system or file structure based on the idea of folders, or the ability to put things in file items inside of a folder and organize them. And the idea was that unlike a real file folder system, you can put folders within folders, and so you have nesting, the capability of nesting items. So like in this picture here, we see that, for example, we have a program file folder. It's called program file. And within it, we have another folder called accessories. And then within it, we have additional folders. And so here we, at the top, it says program file accessories. And then over here in this area of the Explorer, they call this program, by the way, that we're looking at here on the screen, that's called the Explorer. It's a program that runs in Windows. And it helps us to look at the file system in it using a graphical user interface. But we can see that within the folder called Accessories, which is located within the folder called Program Files, we have both files and other folders. And there really is no limit to how far you could nest things like that, but typically they don't go much deeper than maybe 10 or 12 or 20 levels deep. That would be about as deep as it needs to go, because that builds up pretty fast. But you can look at the file system in Windows. Let me switch over here back to Windows again. We can look at the file system a number of different ways. One way is to go to My Computer and just look at the main file system, which is the C drive. And there we see we're at what they call the root of the file system. C colon is the root of the hard drive. Now you can have more than one hard drive on a computer. You could have a D drive as well, for example. Now you might wonder, why is it called the C drive? How did it get named that? Or why did it get lettered C and not B? Because there's an A drive, there could be a floppy disk. That was the original floppy disk, if you had one floppy disk. Well, the reason why it's C is because the original IBM PC could have two floppy disks. So we could have an A drive and a B drive, and still to this day, you could have two floppy disks. Now most people don't even have one because they're obsolete. But that's why it's called the C drive, because the hard drive came after the floppy disk, and they added that, and when they added the hard drives, they called it the C drive, and we still use that terminology today. So here's the C drive, and inside of it we have some folders here. One of them is the Program Files folder I showed you a moment ago. Documents and Settings, Windows. Let's say I open one of these. I'll open the one called Windows. Windows XP warns us that there's stuff in here we shouldn't change because this is part of the operating system, but you can look in there and you see that it's full of a whole bunch of other folders, and the folders are named. Now those are not files, they're containers for files, but we also have below them here a number of different files as well. By the way, you can go to full screen on your virtual box there, so it looks just like when it's running, taking up the whole screen like it normally would. So it looks a little brighter when I do that. I really like VirtualBox. There's other programs like that. If you have Apple, you can do the same thing on an Apple computer and run Windows on it, or if you have Linux, of course I'm doing that, and you can also run Linux on Windows this way, or you can run OS X on Windows, or you could run operating systems that you want to play around with that you might not really want to install on your computer. You just want to see how they work, and you can do all kinds of neat things with virtual machines. This is an example of virtualization here. See, the programs that are running in Windows here, they don't know that they're not running on a real computer. They think they are. They work just like they do. I even had it working where I could hook up my iPod to it, and it had iTunes running there. And as far as it knew, it thought it was running on a real computer. It didn't know. So we have all these folders, and then we have files. Here's files down here. Each of the files has a particular type to it, and a type of file, and it has a name. So how does the operating system know what kind of file these are? Because it obviously knows something about the type of file they are, because it uses different icons, the little pictures that it uses to represent them varies. Like these are some kind of text file here, because they show a little picture of a piece of paper, and this is a program with the little blocks there, and then there's some other programs. Here's a picture file. How does the operating system know that? Which is which? I'm going to go back here to our... Well, we'll talk about that in a minute. How does the operating system keep track of all those different files? That's a lot of stuff, a lot of information. Well, it does that through a thing called the File Allocation Table, or FAT. And it's a table that locates each of the files and all the things that are in the file. And the original IBM PC had a 12-bit FAT table, File Allocation Table, so it was called FAT12. 12 bits means it used 12 binary ones and zeros, binary digits, to locate the information. That meant that the floppy disk was divided up into a maximum of 4,096 different locations. Well, that wasn't big enough for hard drives, because hard drives could store more than 4,096 different locations. Now we'll talk about locations more in our chapter on hard drives, but we do talk a little bit about it in this part too, and those locations are called granules or allocation units, and they're the smallest piece that you can access by a number on the hard drive. They're the smallest place that you can ask the BIOS to fetch for you. You tell the BIOS, I want such and such piece of information on the hard drive, and it's numbered, and so in the 12-bit system it could only have 4,096 of those. With a 16-bit system it could have 50,000 of them, about. And with a 32-bit, it could have 4 billion different locations. Today, our PCs today, we can run the 32-bit. You wouldn't want to run the 16-bit unless you had a really small hard drive. But the hard drives got too big for that, so they went to 32-bit. So you can still run FAT32, and even the most latest version of Windows 7 can still read and write to FAT32 drives. But today we use NTFS with Windows. That's New Technology File System, and it really has the capability of going all the way to 64 bits. That meaning it could access octillions of things. It's a huge number, and it's so big that we don't anticipate running out of capacity for many years to come. You know, who knows what breakthroughs will come down the line in the future. They might have new kinds of storage where they use molecules to store information, and in which case maybe NTFS won't be big enough either. But for the time being, it's going to be able to store enough for any conceivable technology that we can see on the future there. So that's just some examples of that, of different file systems, file structures. Other things operating systems do for us. Operating systems are responsible for configuring the computer's hardware and applications that run on it. And so, for example, the operating system needs to know about the different resources the computer has available to it, like the system memory, the kind of video adapter and its capabilities, things that you can set. So these configurations are like settings. How do we configure things in Windows? Well, we would use the control panel that I showed you just a moment. There's various configurations that we can set in that control panel. And the way that different operating systems store their configurations has changed over the years. The disk operating system had a special text file called config.sys. Config.sys is still in Windows. If you look in Windows, you can still find it, but it's just there for backward compatibility, so that so old programs can still use it if need be. The problem was that using a text file, if a new program was installed that needed to use the resources of the computer somewhat differently, it would go in and change the config.sys file. But sometimes it would change it in such a way as to cause another program not to work correctly. So sometimes we would install one program and it would mess up another program. And there were a lot of headaches that happened in the old DOS, the old version of the operating system. When Microsoft came out with their Windows, they did the same thing again. They used the same kind of files, and the Windows 3 family of operating systems still had that kind of a problem. Sometimes you'd install a new program in Windows and it would cause interference to another program. So they had to come up with something to fix this problem, and what they did was they created what they call the registry. And so modern versions of the operating system use a registry. A registry is a database. And what that means is that when you put settings into the registry, each program or application and each category of hardware, drivers, things like that, each get their own set of entries, and they can't go writing information into other programs and other pieces of hardware. They can't interfere with each other. They can't overwrite each other. And the registry keeps them separate, for the most part. Unless the registry happens to get fouled up, which does happen sometimes. And one of the things a PC technician sometimes has to do is to restore the registry or modify the registry in some way to make it work again. That can happen. So it's not perfect, but it was a big improvement over the earlier text-based file system like Windows, early versions of Windows and DOS had. There's a program called regedit. In fact, when we were in our, let me go back over here to the virtual machine. You notice right there it is. There's regedit. It happens to be on the screen. That's a program. If I click on that, it opens up this editor. It's called the registry editor. And what you can go in there and you can modify the registry. The registry is organized as almost like the file system. It's organized with folders. And it divides things up into for different application programs and for different users of the computer. So you can have different users log in to Windows XP or Windows Vista or Windows 7, and they each get their own settings and their own sets of programs and the way the programs are set up. And also, each program has its own settings in there. And then you can open up a folder, and like under local machine here, there's different programs, different application programs, and each one of them has its own folder to put its settings in. So it's a lot better than just having a big long text file that you'd open up and could get corrupted. It was a lot better organization than the old system had.